The main purpose of the builder pattern is to avoid having complex constructors. In general, you should avoid having a constructor that takes a large number of parameters. Long lists of parameters are confusing and do not give you much flexibility when creating a class. Consider the case of a class representing a person. Each new person created will have a unique combination of characteristics. For example, each person will have a name, age, hair colour, eye colour, occupation, nationality, and so on and so forth. In a Java application, every time a person was created, all of this information would have to be passed into the constructor. This is a very long list that needs to be supplied, and it is easy to see how items might be put in the wrong order. There might also be times in the application where not all of the information is needed. You might need to create a person, but only want to specify their name. To create a person, you would still have to supply all of the other information about their hair colour, nationality, current city, etc. One way to fix this problem is to have multiple constructors. There could be one that takes all the parameters and another that takes just the name. Then, if one was needed, there could be another constructor that takes just the first two parameters, name and age. Then there could be one that takes the first three, and then the first four, and so on until all the parameters are added. This technique is called the telescoping constructor pattern. The problem with this technique is the class ends up having a very large number of constructors. There may be times when you want to specify other combinations, for example, just nationality and date of birth. To have a constructor for every possible combination of 8 parameters, there would be 254 different constructors. This solution does work, and there would be a huge amount of flexibility in creating person objects. But the person class would be extremely long and complex just from the number of constructors. It would take a long time to write all this code, and it would be difficult for other people to read and understand. The builder pattern is a much better alternative to solving this problem. It keeps all the flexibility of the telescoping approach, but without the complexity. It moves the construction of complex objects out of the constructor. It also allows for different combinations of fields with one single construction process. Classes that use the builder pattern scale much better and are far easier to read in this scenario. In this example, there is an application with a complex constructor that would benefit from using the builder pattern. The application has a class called bedroom, which has 8 different fields. It also has an architect class that can be used to create bedroom objects. In the application's current state, it is only possible to create a bedroom if all 8 pieces of information are supplied. None of them are optional because they are all used in the single constructor of the bedroom class. It is also very difficult to tell what all the different information is about when a bedroom object is created. It is also a requirement of this application to have flexibility. You should be able to create a bedroom with any combination of these pieces of information. One option is to go about implementing a different constructor for all of the implementations. This would take a very long time to write out, and make our room class very long and messy. A better idea is to implement the builder pattern. In the builder pattern, there are several components, including a director, a product, and a builder. In this example, the director is the architect's class. The director is used for constructing objects using the builder. The product is the complex object that needs to be constructed. In this case, the complex object is the bedroom. The element that is currently missing from this example is the builder, which is used for constructing the parts of the complex object. I am using the NetBeans IDE, and with NetBeans a builder class can be created automatically. The same functionality is also available in the IntelliJ IDE and with plugins in Eclipse. This is useful because it saves a lot of time from not having to write out all the boilerplate code. To create a builder using NetBeans, I have to right-click on the constructor of the bedroom class. In the menu that appears, I then go to Refactor and click on Replace Constructor with Builder. A pop-up window now appears listing all the parameters in the bedroom class. I now have the option to choose which fields I would like to create setters for. Because I want to have as much flexibility as possible, I will select all of them. I then click on Refactor. A list of warnings now appears telling me that none of the fields have default values. This just means that if I do not set a field, its value will be null rather than a default value that I could specify now. It is okay for values to be null, so I can click on Refactor again. There is now a bedroom builder class that can set all of our optional values. It also has a create bedroom method that builds the bedroom. If I go back to the architect class, I can see that it is much clearer what all of the information means. I could also create a new bedroom object and only specify one piece of information, such as which floor of the building it is on. Even though the room class still has a long and complex constructor, using the builder pattern has abstracted the complexity. Room objects can now be created simply and with flexibility. In this section, I will refactor the example application to create a more complete builder pattern. Currently, it uses a simple builder to create bedroom objects. The architect class creates bedroom objects by specifying the characteristics of the bedrooms that are needed. However, it would be useful if it was possible to create different kinds of rooms, such as kitchens, bathrooms, and so on. In the classic builder pattern, the builder class is actually an abstract interface. In this example, there could be an interface that defines methods for building rooms in general, and there could be different concrete builders for different types of rooms. This would be useful because building a bedroom has some of the same requirements for building a kitchen, but in some respects is very different. To achieve this, the first thing we need to do is to create the abstract interface. In NetBeans, it is easy to create an interface from an existing class. On the left of the screen, there is a menu called Projects. First, I need to right-click on the Bedroom Builder class in the Projects menu. I then go to Refactor and click on Extract Interface. It then comes up with a list of the methods I could have in my interface. Most of these methods are applicable to rooms in general, for example, its dimensions and which floor it is on. So I will select these ones. However, the methods to see if it is a double room and if it is an ensuite are specific to bedrooms, so I will not select those. The Create Bedroom method is also specific to the Bedroom Builder class as it returns a bedroom object, so I will also not select that one. There is also an option to rename the interface, so I will rename it to Builder and click on Refactor. Finally, the return types of the interface are by default set to Bedroom Builder, but the return types should be Builder, and the specific type of builder can be specified when the methods are implemented in the concrete builders. Now it is possible to have different implementations of the builder for different rooms. All of the builders will need methods to set the dimensions, floor number, number of windows, and so on, but they can also have other methods that are not in the Bedroom Builder class. For example, a kitchen builder might also have methods to specify if it has a dishwasher or has a microwave. There would also need to be a new class called Kitchen, which the kitchen builder would build. A further change we could make is to have an abstract class called Room, which all of our different rooms would implement. However, in the classic builder pattern, this is not necessary. Usually, the products produced by the concrete builders are so different that it is not worth doing this. The application is now a more complete example of the classic builder pattern, and can easily be extended to accommodate other room types. The builder pattern can also be useful when a program has complex constructions. In this example, the architect class is used to create a house. The house takes a list of rooms as its constructor. The room objects are created using a room builder class, which is good because that means that there is no need to use a long and complex constructor. The rooms can have as many or few characteristics specified as needed. However, creating a house is still quite complex. Each new room has to be created individually. Then, a new array list has to be created to store the rooms. And then, each room needs to be added to that array list. Only then can a house object be created. The builder pattern has already been used to simplify creating a room, but it can be used again to simplify this further. The application also has a class called RoomListBuilder, which builds the list of rooms. The first method declared in this class is called addList, and this returns a new array list to store rooms in. The second method adds a room to this list, and the final method, buildList, returns the list of rooms. So in the architect class, the code to create a new list and add each room can be replaced with a single line of code that uses the RoomListBuilder. In a single line, the list of rooms is created, all the rooms are added to the list, and the list is built. This could be still further enhanced if the rooms could be built while the list of rooms is being built. Then the whole process of creating the list of rooms would be in a single line of code. To achieve this, both the Room List Builder class and the Room Builder class have been changed slightly. Firstly, there is a second addRoom method in Room List Builder. Instead of taking a room as a parameter and adding it to the list, it just returns a new Room Builder. In Java, it is okay to have two methods with the same name if they take different parameters. Note that the Room List Builder needs to be a field of the Room Builder class, and also that there needs to be a second constructor of the Room Builder class that takes a Room List Builder as a parameter. Then, there is a method that adds the room to the list of rooms. The first thing this method does is build the room. Then it adds the room to the list and returns the list. Now that these two methods have been added, it is much simpler to create a list of rooms in the Architect class. A new Room List Builder is created, and then the addRoom method is called. At this point, the features of the room can be specified. Then the addRoomToList method adds the room to the list of rooms. When all the necessary rooms have been added, the buildList method is called to finish building the list. The code to create the room classes at the top of the method are no longer needed. This use of the builder method has made our code in the Architect class shorter and more fluent, but it is still just as easy to read and understand.